We go ahead, Let's go to the first order of the reaction. That was zero order of the reaction. Let's go to this first order of the reaction. So first order of the reaction. What is the integrated electron formula? The integrated electron formula is equal to what? The natural log of what? Initial concentration, the natural log of concentration which depends on time is equal to negative KT, which is the rate constant times time plus the initial concentration. Let me say the natural log of what? The initial concentration. This is the integrated electron. Integrated electron. What about the half-life? The half-life formula of integrated electron. I'm going to use the same formula, of which I'm going to say initial concentration. Let me say I had a natural log of what? Making everything as initial concentration because we're deriving a formula here. The initial concentration of what? The initial concentration, and make this one divided by 2 because let's say half of it, we are looking at half, so I'm going to divide by 2 because of half of what? Any initial concentration that have been given is equal to, I'm trying to develop an assumption there, negative KT plus the initial concentration. I'm going to just introduce that divided by 2 on one side. Okay, and that simply means to say, if I'm to get this one, or maybe just to change the position of which there will be one and the same by changing the position, I say negative KT plus initial concentration. Let me say the natural log of initial concentration is equal to the natural log of what? Initial concentration divided by what? 2. In this case, what's going to happen is this. Not that I'm looking for the time taken. So I say negative KT, first of all I hold on that, is equal to the natural log of initial concentration divided by 2. When this one comes, this side will be minus the in, which is the natural concentration or natural log of what? Initial concentration. Note that what I've done here, going back in logarithms, what's going to happen is that the in, whatever there is in, whatever there is subtraction goes in hand with what? Division. That's according to the rules of what? Logarithm. So I say KT is equal to, if I say in, open brackets. So then I say the initial concentration over 2, which is this, because of having get one thing here, and that's what there is the subtraction. Then if I follow the rules of logarithm, that goes with what? Goes with the division. Divide by this A, which is the initial concentration of that A. So if you see very much properly, this minus turns into what? Into division. Then this, which is this, minus turns into a division, having getting one what? Natural log. So then I say negative KT is equal to the in, and I can maintain what is there, or let me say parallelize what is there inside, which I say the natural log of or let me say initial concentration of A, divided by 2. Then this one, which simply means divide by the initial what? Concentration of A. Then I go ahead, I say negative KT is equal to the in. This simply means initial concentration of A divided by 2. Same applies what if I'm trying to flip it, which I might affect this one, I say over what? The initial concentration of A, because I know to say the initial concentration is being divided by A, because this of if I say initial concentration divided by 1, that is initial concentration. So of which if I flip it will be in this form. So I say negative KT is equal to the in, which is initial concentration. Initial concentration times 1, that is what? That is initial concentration. Divided by 2 times initial concentration, that is what? 2 initial concentration. Then I say negative KT is equal to the in, which is initial concentration. This goes. What I'm going to remain with there, I'm going to remain with what? 2. So this is negative. I cannot find the value of negative kt or negative t, but I'm finding the value of what? T. So what's going to happen? Allow me to eliminate first of all a negative here. I'm applying negative times everything here to be what? This side I'll be having a positive there, then say negative times this one to be negative in, which is negative natural log 1 over 2. And if you have to punch at your calculator, say, what is negative 1, negative log? I mean negative in, or negative natural log of that one, open brackets, 1 over 2. What's the answer there? The answer is 0. What? 0 0.6c, 0.693, which I say kt is equal to 693, of which I say divide by, I'm looking for value of k, for value of t, divide by k, which is rate constant, goes, and my value of t, which is half-life, is equal to 0.693 over k, which is rate constant. And if you see very much properly, what is happening here, this same applies, because I know to say the in or the negative in over 2, same applies the half-life of 1 over 2, which is equal to what? The in or negative natural log of 1 over 2 is equal to what? Or same applies with what? The in of 2, which is natural log of 2 divided by what? K. Because if you punch it is giving you one and the same, which is 0.693. So if you have to say 0 or in of 2, that is what? 0.693, which is one and the same. Step rest. Thank you very much. See you in the second order of the reaction to deliver the formula. Thank you very much. Stay blessed. Don't forget to subscribe, like, comment. This is the Sinkara. Stay blessed.